So your overarching learning goal for the entire chapter is here. I want you to be able to define basic chemistry terms, and we talked about that in the first lesson, like chemistry, mass, matter, etc. You'll have a few easy fill-in questions on your quiz. Convert and calculate quantities. That's what we're going to focus on mostly today. You know how to do very simple conversions. Today we're going to focus more on complex conversions, whether you're going metric to English, English to metric, or within the metric system you actually can change between the amount of substance and the volume of substance. And I'll walk you through that today. Next week we'll get into expressing quantities in the correct number of significant figures, classifying matter, as well as properties and changes in matter will be more for next week, and you'll have your first lab next week as well. So we had talked previously about simple conversions, and I think most of you feel pretty comfortable about this. Just remember down, right, up, left, and you'll be very successful with that concept. What we want to talk about today are conversions within different types of quantities. As I mentioned, either English to metric, vice versa. You can have multi-step conversions. And when you want to make these types of conversions, you're going to use a method known as the factor label method. In chemistry, we call it the factor label method. In physics classes, they tend to call it dimensional analysis, and those terms are synonymous, so either one is fine. And what this method allows you to do is it allows your units to drive your problem, and I'll show you what I mean there. And this is something that you probably did in 7th grade advanced math. It's something that's extremely useful for your PSATs that you'll take this year, as well as your SATs. Very often when we do any type of problem solving, I'll list the steps involved to do the problem, so that if you are working on something at home and you get stuck, you have these steps to go back to, and this will just give you guidance so that you can work through the problem successfully. So the steps are here, and I'll go through these with you now, although they won't really click for you until we work through the problems. So I'll go through the steps, and then we're going to work through a whole series of problems today, and there are actually 10 of them, and then I'm going to leave you with 14 problems to do. And by the time you get done with the 24 problems, I think you'll feel very comfortable. As I mentioned several times already in chemistry, you have to practice, you have to practice, you have to practice, okay? So your first step is to write down the information provided. Now these problems are going to be pretty straightforward because the given and the unknown are going to be very clear, but in a word problem, your given is going to be a quantity, a number and a unit. Unknown is what you're solving for. You want to figure out which equalities are going to help you make that conversion. And your equalities or conversion factors are listed here. These will be given to you. You do not need to memorize them. So they will be provided to you on any quiz or test. So you don't need to memorize these. Now any conversion that you can make from the scale alone, like 1 liter is equal to 1,000 milliliters, that you have to be able to derive yourself. But these conversions will be provided to you, so you don't need to memorize. Your focus this year is on doing, not so much memorization. Once you've figured out which equality is going to work, you're going to insert that equality or multiple equalities to make the conversion work. I'll show you what I mean there. You'll cancel anything you can, and you'll calculate your answer. So these are the equalities we're going to be working with, and I'm sure you're familiar with many of them. Some of them are in English. Some of them will be more of in English to metric. Sometimes you'll be within the metric system, so a lot of conversions there. And we're going to work through each of these problems now very slowly initially so you can see the solving. I know a lot of you probably can do them in your head. It's really important that you show your work. You'll see in chemistry, if you're very neat with your setup, it's much more likely that you will be successful in the solving process. When you get to more advanced chemistry at the end of the year, you will see problems such as those on the screen. And I don't want you to absorb this per se. What I want you to see is that you've got multiple steps along the way. And as a result, learning how to do the factor label method effectively is critically important for success in chemistry. Alrighty, so the first problem, this is my height. I'm 63 inches. I'm a giant. I'm a giant in my family because they're all really small. So at 5'3", I'm a giant because my mom's like 4'10". My sister's not even 5 feet. My grandma was like 4'9". She was puny. Such a cutie. All right. So let's say I'm going over to Europe and I want to get a driver's license. I can't report my height in inches. I need to report my height in centimeters. So I want to know how many centimeters are equivalent to 63 inches. So what I do is I look at my equalities. And when I look at my equalities, I look to see if there is an equality that has both inches and centimeters in it. Do you see one? Yeah, it's the first one right here. So this is my equality. So I know that 2.54 centimeters is equal to 1 inch. And an inch is like from that knuckle to that knuckle right there. I don't know, is that going to show? Let's see. How can I do that? Right there. That's like an inch. Now with this equality, I can write this one of two ways. I can write 2.54 centimeters over 1 inch, or I can write 1 inch over 2.54 centimeters. If the equality has both the given unit and the unknown unit in it, the problem is one step. You're going to multiply it by one fraction. Whatever unit you start with is the unit that you want in the denominator of that fraction. So you're going to pick this one because inches is in the denominator. And the reason why you will pick that, well, what do you think? Why do you think I wanted inches in the denominator? What happens to units when you divide them? They will, starts with a C, cancel. So you'll get those units to cancel. Now you have the unit you want, and all you need to do is multiply 63 times 2.54, and that's about 160. You will need a calculator today. If you don't have a calculator, I have a whole bunch on my desk, and you are welcome to borrow one. Just please make sure you return it at the end, otherwise I'll need to do a little loaning system. This is the easy one to use, much easier. So 2.54 times 63 is 160.02. I'll teach you how to round next week. Why did I put inches in the denominator of the first fraction? So the unit would cancel. All right? Does that make sense? Yes? Okay. The second problem is actually 1B. And that is 462 grams. And you want to get 2 ounces. Which conversion factor should you use? Okay, Angelina, who are you?
Oh, she switched out.
Oh, she's gone. Can't call on her. Haley. Who's Haley? Hi, Haley.
Hi.
Which conversion factor?
An ounce?
Yeah, you want to get to ounces, you want to get rid of grams. So is there an equality that has both grams and ounces in it? Look in the third column.
No.
Are you sure?
Yeah.
Third column, second from the bottom.
I don't know if I'm right small. Oh, that means?
They're right above your problems that we're doing.
Oh.
You can phone a friend.
So 28.3 grams equals 1 ounce.
Thank you. Can you show it to her, please? Thank you. All right, so which part of that equality is going in the denominator? Who are you? What?
Right.
Got it. Go ahead.
On the grams.
Perfect. 28.3 grams. Why'd you put the grams there?
So we cancel out.
You got it. And 1 ounce goes on top. Now, never divorce a quantity. If the 1 is with the ounce, it stays with the ounce. We don't divorce quantities. It's too expensive. Now, this is like one giant fraction. So we're going to divide 462 divided by 28.3. And that's going to be 16.3 ounces. How we doing? Easy peasy so far? Cool, let's turn up the heat. On number 2, we have 5 kilometers. And for those of you who run track, cross country, etc., you may have run in a 5K race. That's a 5-kilometer race. Years ago when we used to do running in high school, way back in the day when I was there, at least like 100 years ago, we didn't do K races. We did like 40-yard dashes, and we would run 5 miles and things like that. So if we wanted to convert kilometers to feet, is there a conversion that has both kilometers and feet in it? I don't see one. What do you see?
I don't see 1 one, but there's two that you can use.
Okay, so what are those two?
The 1 kilometer equals 0.62 miles, and then the 5,280 feet equals 1 mile.
5,280 feet, yes. All right, so we need two equalities to get there. So how many steps is this going to be? 2. So we're going to need 2 fractions. And what quantity is going to go in the bottom of the first fraction? And Dora?
The 1 kilometer.
You got it. Why are you going to put 1 kilometer there?
So they can cancel out.
Cancel the unit. You got it. And with the 1 kilometer goes the 0.62 miles. So now you'll be in miles, but you want to get to feet. So what's going to go in the denominator of this second fraction, Brian?
Mile.
The mile. And what number goes with the mile?
1.
Yeah. And now you can multiply all those numerators off. You have 5 times 0.62 times 5280, and that's going to be 16,368 feet. I would like for you to try number 3, which is 462 grams, and you want to get it to pounds. Try and set it up. I want to see how you're doing. Wow, that's crooked. So what'd you do? What'd you do? So did you go grams to ounces first? Okay, so previously we knew 1 ounce is 28.3 grams. The grams will cancel. Now ounces to pounds. How do you do that?
16 pounds is a pound.
Say it again.
How many ounces are in pounds?
So where are you going to put the ounces?
One.
How many?
16.
Right. 16 ounces in 1 pound. Now the only other thing I want to really point out here is keep in mind this is like one big fraction, but if you have more than one quantity in the denominator, you're going to have to parenthesis it off in your calculator, otherwise you may make a calculation error. So you have 462 divided by open parenthesis 28.3 times 16 close equals 1.02 pounds. Did you calculate the answer correctly? Yes? Okay, great. The next problem is relatively straightforward in regard to the setup. However, in terms of entering that first given quantity into your calculator, you may need a little assistance. You have different calculators, so you may have a different button to press, and I will do my best to get around to each of you so that I can show you where that button is, but I'll explain it here. On number 4, and I'm actually going to turn my page sideways now because some of these problems are going to get lengthy and it'll be easier to work in a landscape configuration. So on this problem, number 4, we have 3.21 times 10 to the 9 seconds, and we want to get to days. And I'm going to work through these equalities. You don't have to write them all down underneath unless you feel like it's helpful to you. If seconds is here, I need seconds here. And I know in 1 minute there are 60 seconds. Now I want minutes to cancel, and I know in 1 hour there are 60 minutes. Now minutes cancel. And for hours, I know in 1 day there are 24 hours. So now hours cancels. Again, this is like one big fraction. And you want to parenthesis off the bottom. And the only piece that may be tricky for you is entering this into your calculator. Can you see the screen here? Instead of typing in 3.2 times 10 to the 9, instead of the times 10 button, I want you to hit either the EE button or the EXP button. If you have a multi-view, it's a little bit different. Look for that button. On mine, I have 3.21 EE. 1 E shows in the display. 9. divided by open parenthesis 60 times 60 times 24 close equals, and that's 37,153 days. And again, I'll teach you how to round next week. Let me come around and make sure you can find that button. Did you find it? Yours is going to be here. So you're going to do 3.21, this button, and then the 9, and then divided by open parentheses in the whole bottom. So you have that button. You found it? The easy button? Yes? 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 Which one? This one? So Millie, right, you're going up. So Millie, yeah, so you're going up 3. Up 3, because there's spaces in between. So you better have 1, 2, 3. 1, 2, 3. And this one, micro, mass, so here's micro, all with the here, so you have up 6. And check the this. Good? All right. I would like you to try number 5. Number 5 says 3.53 moles, and we want to get 2 molecules. Give it a shot. How'd we do on 5? The answer to 5 is right here. And don't forget, instead of times 10, we're going to use that EE or EXP button depending on your calculator. Did you get this for 5? 2.13 times 10 to the 24th molecules? Yes? Good. Please try 6. I'll put 6 back up on the screen so you can see it. So on 6, I got 0.00428 or 4.28 times 10 to the negative 3 moles. Yes?
Can you go over how to do that one?
This one? Sure. Were you able to set it up properly?
Yes.
Okay. In your calculator then, keep in mind this is like one big fraction. And so in your calculator, what you want to do is you want 2.58 EE21 divided by 6.022 EE23 as such. Did you multiply?
Yeah.
Did you get times 10 to the 40 something?
Yeah.
Yeah, so you multiply, but this is like one big fraction, so it's division. Does that make sense?
Yes.
Okay, great.
Can you go to the calculator?
Sure, you just want to see what it looks like in there? And I can switch to one like yours if it's easier. The multi-view, very few of you have multi-views. I'll show you that separately. If you're not really attached to that calculator, I'd get one of these because those are really a problem to use. So in this calculator here, you have 2.58 EE21 divided by 6.022 EE23 equals. If you have a multi-view, that denominator has to be in parentheses also. If you don't, then it doesn't. All right, I do want to do a couple of more complex ones with you. 6B is pretty straightforward. I'll leave that for you for the second half. But I'd like to work through at least 7 and 8 with you, let you try 9, and then we'll break, and then you'll have the remainder of the period just to practice, so that by the time you work through 14 problems, I think you'll have that big aha moment and you'll be like, this is easy. This first quiz next week is very simple. I feel really confident that you'll do extremely well on it. We'll hold 6B for now. I'll let you work on that one afterward, but I'll put the answer with the work shown up when the time comes. I want to work through 7, 8, and 9 with you. Those are a little more challenging because they require both a decimal point slide, if you will, and a conversion, and I'll show you what I mean here. On number 7, they give you 4.62 milligrams, and we want to get to pounds. And sometimes there is more than one way to do a problem. On your equality list, do you see milligrams to pounds? No. Do you see pounds to something? You see pounds to kilograms, right? Let's try that. So we know that 1 kilogram is 2.2 pounds. So let's think backward. If I want to get to pounds, then I'm going to need pounds in the numerator of the last fraction. So I'm thinking 2.2 pounds here to 1 kilogram. I don't see a milligram to kilogram conversion, but you have the same base unit, which is grams, which means you could make a conversion between milligrams and kilograms. And how could you make that? If you go from milligram to kilogram, you could say 1 milligram. And now, would I go up or down to get to the kilogram? Up. How many? 1, 2, 3, 4, 5, 6. So that would be 1 times 10 to the negative 6. So you could make an equality. And in doing so, you have the missing piece. And we're going to do a couple of these. This is a little trickier. If milligrams is here, then I'm going to put the 1 milligram here. And the 1 times 10 to the negative 6 kilograms here. And I've got my problem. I have 1.02 times 10 to the negative 5 pounds. So sometimes you have to make your own equality. And 8 is very similar. I'll walk through this one with you carefully, and then I'm going to have you try a couple before I let you really practice hard on it. Let's take a look at 8, and you're going to have to really talk me through 8. 8 says 12.4 millimoles, and we want to get to molecules. Is there a conversion that has millimoles and molecules in it? No. What's the only conversion you have with molecules?
Molecules to moles.
All right, so 1 mole is 6.022 times 10 to the 23rd molecules. Now some books will just write 6.02 times 10 to the 23rd. Don't worry about it. All right. So now what are you thinking? Is that conversion going to be used in the beginning or the end? The end. And why does the 6.022 times 10 to the 23rd molecules have to go on top? What unit do you want at the end? Molecules. Hence, the last unit in the last numerator has to be on top. All right. Is there a way to go from millimoles to moles? Do you have the same base unit? Yes. So you make your own conversion factor. So if you were to look here, milli would be here. Where would moles be? Base unit. So we could say, you can do it either way. Do you like to go up or down? You want to go up or down? You want to go up? So then start low. 1 millimole is how many moles? One times 10 to the what? -3, because you went up. Now, I personally like to go down. I think it's easier, but whatever rocks your world is fine. You could have done it this way. Either one is fine. I like to go down. Pick one of these.
Good morning. Please pardon the interruption. Teachers of juniors at this time, please release our juniors down to the auditorium for this morning's junior ring assembly. Students, please bring your belongings with you as you will be going to your next class from the auditorium. Also, make sure you have something to write. Teachers, please stay in the auditorium with your class.
I'm going to use this fraction because that's the one that you had said initially. From the one underlined in red, what must go in the denominator?
The 1 millimole,
Why?
because it has to cancel out.
You got it. And now the mole will cancel and you'll multiply off here. And you get 7.47 times 10 to the 21 molecules. Yes. You want me to plug it in? Yeah. Off this guy? Okay. So you have 12.4 times 1 EE negative 3 times 6.022 EE 23 equals. Are you hitting your EE button? All right, I'll watch you do it. Oh, okay. So you put it in. If it doesn't come out properly, I'll physically watch you do it. Does that make sense? All right. So what you've seen here is the factor label method. Let your units drive your problem. If you don't have an equality that's going to get you from the given to the unknown, you may need to make your own. On your quiz, I'll probably tell you when you need to make your own equality for right now, just to give you a little more confidence. I know you'll be able to do it yourself ultimately, but I don't want you nervous for your first quiz, okay? Factor label method, the units drive the problem. Simple conversions, either within the metric system, sometimes between metric and English, etc. Questions here? Okay, so we're going to break, but what I do want you to do after the break is I want you to do 6B and 9. So you'll do 6B and 9 in your notes to make sure you've got that concept, and I will work those problems out so you can see them on the screen. And then on the classwork that was on your desk this morning, you're going to do section 2, which is the factor label method. And you want to be able to do that section, which I believe is numbers 1 through 14. No, 1 through 18. So that's going to give you a lot of practice. And for this second half, I would recommend that you work in groups of either 2, 3, or 4, productive groups. You can push the desks together, or you can work at the lab tables. For today, this station is never a working station because this is always a lab setup station. I've got 7 stations for you. I can clear this station off pretty easily so that you could work there if you needed to. Otherwise, you can work at the desks. And you had a question.
Yeah, for the classroom, can we do a separate sheet of notebook?
I would do it on a separate sheet of notebook paper because classworks don't always have enough paper to write off of. I just try and make it so I don't have to run so much paper. Questions? All right, so we're working toward that learning goal, and we've got the conversion piece here, and I feel very confident that with practice you'll be highly successful with this section. But you must practice.